Hello, hi. This is part one. So, two research ideas. And again, my source for these two ideas, the ideas are not there. I thought of the ideas, but the research which gave me the ideas came from the book. All right, Horton, Moran, Ron, Ox, and Scrimgeour. Or Horton, Moran, Ox, Ron, and Scrimgeour. It's a book by Prentice Hall, and it was my biochemistry textbook. I have two graduate engineering courses in biochemistry. So, all right. So, first one is all right. tRNA, transfer RNA, is the interpreter of the genetic code. These are the crucial link between messenger RNA, which is a sequence of nucleotides, DNA bases, which are present in these messenger RNA, and the sequence of amino acids in a polypeptide. Or polypeptide can be a protein, but not all polypeptides are, there's a difference. Peptide bond is a CONH bond, and polypeptide would be, protein is a big molecule, huge molecular weight. Polypeptide can be just minimum. I think you need is a tripeptide. So my experiment is to calculate the molecular weight of transfer RNA. So the picture in the book. Let me show you the picture in the book. This is the picture in the book, and this is transfer RNA. And so I would take a small quantity of a vegetable or an herb and see how many molecules of transfer RNA or messenger RNA could be in there. One transfer RNA species for every amino acid. There's one transfer RNA species for every amino acid. And this would be like Mendel's experiment, all right? So you would have to, gram per mole. So how many grams of the veggie you've taken? So you get the number of moles, and then how many molecules are in the mole? Of course, Avogadro's number, and so painstaking experiments like Mendel's study. So I would take three vegetables, narrow it down to three vegetables, and then three herbs, and see which has messenger RNA, which has transfer RNA. There are a few codons given there. Codons are made up of amino acids, and I think each codon represents adenine. Yeah, I think adenine, guanine, guanine, uh, uracil, and cytosine. So so this I need to read up to that's experiment one. Next would be experiment two. Saliva has DNA plus enzymes. This comes from old research, also from a phone call to company which was giving out the genome in all of us, the human genome in all of us. You'd have to. So that I called up, checked, and I said, "Is it cheap? You'd be using my credit card. I just want to see how the process go. What kind of procedure you use." And he said that he would take a saliva swab with a Q-tip, and that is all is required. So what does he want to elaborate? But he was very patient with me. He spoke to me and everything. Very nice gentleman. Anyways, so I would calculate the molecular weight of all the DNA bases, the phosphate, what no, of all of all of these, and see how many molecules of each DNA base plus enzyme can be fitted in. So if I suppose I could get the DNA strings, which are a part of my, of my genetic code. So it would be based on the Crick and Watson model, and then 80 and then a turn, and then there are all these rules, which we know there are all these conditions which go into making the DNA Crick and Watson structure. So you would be A80, GC, and if it turns, so all that if I were to consider, then I possibly, based on the amount of molecules and molecular weight which I come out with, and which how much I measure, I would be able to see my genetic structure. This is also a painstaking study. It's like the Gregor Mendel studies. He worked for years with plants and came out with the laws of heredity. So that was my first presentation. I have a part two coming up, and so when you watch me, you should watch my second part two too. All right, thank you.